All right. So do you want to put one front and center in the middle of the screen then?
Yeah, yeah. I was thinking kind of going into
Or those two? Okay.
the flaring
Perfect.
category first, kind of tackling that. And
All right.
so if we look at the three main functions that Navac has tools for in the tubing realm, that's obviously going to be flaring. That was kind of our flagship start into the tubing tools side of things, as well as expanding or swedging, depending on where you're at, and then also bending. So these are the three main functions. Navac really, to kind of make a bigger splash into the industry, kind of started with some innovations, in the form of power versions. However, just as a reminder to everybody who doesn't hold this in high regard or value for their day to day, we do always have, of course, very robust, very high quality analog and manual versions of these products as well. So yes, for those that would look at something like this, and of course, everybody sees the general, commentary and conversations online, and people tend to love this, or hate it might not be the right word, but they just don't get it. They don't see the worth of something like this, the investment, right? And I would
Well,
say to anybody that has that mindset, immediately they're correct. They shouldn't get it. The
I'm
people
going to
that
be
miss,
honest. I'm going to be honest with you if you let me jump in for 1 second.
of course,
Everybody that I've spoke to that owns the power flaring tool absolutely loves it and says it's one of the best tools they've ever purchased.
and I would second that. I agree that the people that have bought it love it. But for those that have seen it online and just kind of give their opinion on it, if they're thinking of it as an overkill, a luxury, then they're probably right. It probably is for that probably is an individual that flares now and then. Maybe they're not doing a lot of ductless, a lot of mini split installations, a lot of VRF, that type of thing. And then, yeah, 100%, this is overkill. Don't budget for this. I'd rather take the money for something like this and grab a few tubing tools. If I'm doing flares here and there, I'd get a really nice manual flaring block that has a clutch in it. And when you hear the idea of a 45-degree flare or a 410A flare, the only really thing that distinguishes a 410 flare is the need for it to withstand the pressure that it's going to be held under. So the 45 degree and 410A is pretty much synonymous. The considerations when making a 410 flare block is that clutch. The inclusion of the clutch is really the only thing that's realistic when we're talking about the differences, and only meaning this really prevents us from over flaring it, right? And preventing the over flare is preventing it from losing the integrity or the strength of the flare. Other than that, there's not a difference, but we want to make sure everyone knows that we do have such a tool, and they can go with as simple as a manual, and the intermediary would be to get the D version, which stands for drill. So this could be kind of your in-between from a full power option, and have the ability to either do this manually or get your impact or your drill to kind of speed that process up a little bit. And of course, the clutch mechanism still remains intact if you're using it without, with a drill. So
Okay.
overflaring is not a risk in this case.
Okay. So can we
Um,
go through quickly just a demonstration of each one?
yeah, yeah, of course. Let me grab a piece of copper. I'm sure you'll cut this little part and jump ahead to when we've got it ready, but or we'll keep this rolling and use it as an opportunity to talk a little bit about when we are cutting and prepping our copper. It's on the surface an easy task, and most people have no problems with it. But the couple little things to keep in mind are to really try to be aware of how forceful we're being on this. If you notice, some people might be watching this saying, dude, why it should already be cut. But I really make sure to feel no resistance before I give it even probably an eighth to a quarter turn on the wheel. And I do that to really minimize the burr that I'm creating.
Mm-hmm.
Really, the less you can really jam it on during the cutting process, you're adding a little bit time to the cutting, but you're really saving yourself on the deburring. So what'll happen here is either people won't take the extra time to deburr the mess that they created.
Now, the other reason I agree with you. Going soft on the cutter is
Mm-hmm.
something that I do as well. And I notice some cutters will actually start leaving an indentation or a scoring on a part of the pipe too, when you do like go in hard with it and try to cut deep.
I think I missed a little part. Are you talking about when they're deburring, they go too far, or when they're cutting?
When you were cutting and saying how it was taking you long, but you were just applying a little bit of pressure on the wheel, I've
Mm-hmm.
seen it where some cutters, if you apply a lot of pressure on the wheel and you cut the cutter, depending on what style of cutter is, it can leave a bit of a score on the pipe as well.
Absolutely. Absolutely. And we want to avoid anything like that we can. We don't want to have a humongous burr because we don't want to be tempted to go overboard with the deburring as well. You can deburr this and remove too much material. And now you've got a situation where you've weakened the edge of this. And when you do get to the point where you're making your flare, you're really adding to the risk of having little cracks and splits on the edges there, which are going to cause just as much problem as if you didn't use a torque wrench or if you didn't flare or if you underflared, overflared. It's just as equal of a risk. All of these little potentials. A lot of things have to come together for a flare to be, bulletproof. And I believe that the prep is part of that. So we
Yeah,
want to
for
make sure
sure.
that we're easy on the cutter. We want to make sure that we're making a square cut. A lot of people don't think about that too. These things can cut kind of wonky, and you want to have a nice square cut. The other thing is if you're crushing, if you're too hard with the tubing tool, you're not only creating a large burr, but it's hard to. I didn't do it with this piece, but you would be able to see from the side profile, it almost rounds down.
Mm-hmm.
It turns into this squished kind of shape that is no good either for a good flare afterward.
So cut soft, deburr, first two steps.
Cut soft, make sure you deburr the copper. Don't skip
And
that step.
and keep the copper pointed downwards to get the filings to fall outwards.
So great point. I'm obviously not keeping that in mind because I'm on a desktop with a little scrap piece, but you're 100% right to the point where I would, if it came down to it and I had an apprentice with me and we were in a scenario where you could not either angle this down or tap it or, flow nitrogen even while I was doing this, I would probably rather them not even deburr the copper. If the alternative was to leave a bunch of shavings in the tube.
Yes, makes sense.
So lesser of two evils. I'm not advocating for not deburring. There are definitely consequences to not deburring, especially compounded over an entire job. You're making significant impact on the velocity of the refrigerant, which will lead to other issues as well with oil return. But to me, especially if we're talking ductless units, the EEVs and the little filters and strainers, and there's just too much risk to leave even just from what I did here, the camera's not going to pick it up well, but this is like a whole pile right here. This will wreak havoc on the system. And to think that if you did it here, you probably did it on the, 5 or 10 other joints that you had in the installation. So one thing that we want to keep in mind as well with flaring is our depth. And again, different flaring tools will have different mechanisms for that if they've prioritized depth, which we have. So in the case of a manual flaring block, when you go up into your size, which we've got 1/2 inch here, we'd want to close, and then we'd want to make sure that our tubing is right to where that slides over it and barely makes contact to ensure a repeatable and consistent flare shape. It's the same with our battery-operated flaring tool clamps, where we would just move this aside and clear it. We get our tubing into the clamp, and we get it just to where I can push that over, and then I would wiggle this until it kind of butts up onto this slider. And then from there, I'm very confident that we've got a good piece of copper that's set up. Some people will see this too. We've had people say, well, my clamp this isn't closing all the way. You can see this gap. It doesn't look like it's fitting on this clean. Or maybe this is a warranty situation. It's not. This is the built-in play that allows the clamping action to actually secure the tubing.
Squeeze it down.
Once we've got that locked in, this is now positively closed on the tubing. So once that's the situation, this is a one-touch operation to cycle through the entire process. It saved me, however much time, depending how fast you are with a manual flaring block. If you've got one flare in the day to do, again, that technician that argues that there's not a value in this, so be it. But if you're doing this dozens of times a day, it's where this really has been such a wonderful addition to these contractors' tool bags. And as you said, it's from their mouths. The people that install these all the time have really fallen in love with the thing. So you can see too, we've got a gauge. This is kind of our final check and balance on our process. So if we followed all the, kind of the discipline practices up to this point, we still want to have that final, confirmation that we've got a flare that is consistent with the tool's intention. So this is a anodized aluminum plate or bar that has our flare sizes bored through them. We don't want the tube to just pass through to pass. Won't be able to see it on the camera, but there is a small laser etched ridge on the inside of each of these holes about halfway through. So if the tubing were to pass all the way through cleanly, that would suggest that we have underflared our termination. If it doesn't even go in at all, we've clearly overflared, and now it's expanded to the point where it doesn't even fit. For us to consider and call this a perfect flare, we want the tubing to pass in and catch and even be able to stand. It's in a balance, but you can see that that's actually inserted into the hole, but it's not falling through the other side. And that's good. You would feel this. I'm pressing right now and it's not passing through. So I would call this a great flare for the situation.
Can you go over, there's a hex nut on that tool. Can you go over what that's for? Because I've seen some arguments online about what it actually does.
So what we've got here is actually two screws. Two screws. This is a set screw. So you would remove this. What this is basically for, and if I had an Allen key with me right now, I'd do it. Sometimes people's tool gets banged around, knocked around a little bit, and eventually what happens is this thing loses its ability to clamp securely with a positive grip. And then there's some people that'll say, this is very similar for those who've never held this tool. It's like a pair of vice grips. It's the same feel where you tighten down and then you feel a positive clamp. And on a pair of vice grips, there's a thumb screw to be able to set that resistance. And you can obviously have it way too tight and you'll never close the handle. It won't be physically possible, or it's too loose and the thing it just goes all the way down and doesn't ever clamp. So
it's just basically like a vice grip adjustment.
It's exactly what it is. Right.
Perfect.
So we've got a set screw here. We would remove that first. And then from there, and it's kind of hard to see on the camera, there's even instructions here. And it shows what direction it is for tension and reducing tension. So what I typically will do is I'd remove the set screw. Navac has a YouTube video on their channel as well where I do go over this in depth. So if people want to actually see the full process, they can go there. But for just quick reference, I remove the set screw. I get my Allen wrench ready in this already. I put my clamp into the tool, and then I just put firm pressure on the handle at the same time as I begin my adjustment. So instead of making small adjustments, putting it in, checking, small adjustments, I apply pressure the whole time and I slowly turn the Allen wrench until it eventually pops. And I feel confident at that point that I've dialed it in precisely for my hand strength. And as soon as I pop that in, I pull the Allen wrench out and then I get my set screw back in to lock that setting into place. And that is what those are for. There is an inadvertent secondary result of playing with the screw too much, and it can affect the size of the flare. So there have been times in the past where people have used this to try to dial in their actual flare size. But to me, 90% of the time, that's not the answer. And it's probably more likely that they have an issue with the alignment of the tool or their clamp has maybe failed in some way. But I have heard some people be able to use that with success, but only in very small case where it only needed a very minute adjustment. If you're having to back this out a lot, you've got a bigger issue. So, So from start to finish, whether it was a manual flare or a power flare, we advocate the same discipline of deburring properly, cutting squarely, using a depth gauge of some sort, depending on your tool, and then verifying your work afterward with a flare gauge. The extra step of doing this saves you a lot of problems down the road if you've got to go back on a job site because your flare leaked. So
sweet. Okay. So we can move on. You want to move on to the bender then? Do you want to do the ratchet and power bender? You got those right in front of you too, right?
Yeah. Let me go ahead and swap this stuff over. Let's take the two longer pieces. So what we've got here too is the Navac lineup of bending tools. Again, we kind of came to the market first with our kind of innovative power bender, first in class of its kind, using a 7-volt battery essentially to bend up to 7/8 tubing. And then afterward, due to, again, the understanding that we have people that have different budgetary priorities, we do have the kind of classic Me Too ratchet bender design. So this can use either the T-bar that it comes with. It also can accommodate the T-bar of our power. So if you'd already bought this and for some reason wanted to have a backup, or something of that nature, the same mandrels and T-bar will work here as well. So this is pretty cut and dry. You've got a manual release. Well, see, so pro tip, don't aim this at the TV monitor before you try to throw it off there. We're using a ratchet mechanism to bring the tubing up to our knobs here, which are adjustable based off the tubing you've got. And once you've completed your desired bend, you break the handle backwards to release the mandrel down and allow you to remove your copper at that point. The graduations of each ratchet is the limitation of your bend precision. So in other words, one of the benefits to a power version is, one, the obvious fatigue that comes with hand ratcheting over time, especially with 7/8. I've pretty much had this open challenge anytime I go to trade shows, that if somebody can crank out a 90 from start to finish with one hand, with a ratchet style bender of any manufacturer, it depends on the show and what I have in my wallet, but it's usually between $50 and $100 that I offer. It's very difficult to get through, and I'm not a small guy, and I'm not a weak guy, and I usually by the end need to get a second hand involved. So I know there's a lot of built-in jokes here that we could go into, but
do you have any 7/8 there? Do you have any 7/8 there?
Yeah. If you want to grab a piece, I'll demonstrate.
Okay. Should you and Jesse race, or are you going to do it with both hands?
Well, I'm bringing Jesse. Now you're making it the conversation. I don't want to really talk right now because I feel like it could be edited in a way that really shows me in a different light than I'd prefer to be. But the two hand with Jesse, like I'll show you, before we're done here on a 7/8 piece of tubing. While he's cutting that, I'll just go through real quick on the power bender. Same principles. We've got a bar here. We need to make our adjustments. Basically one adjustment. You've got obviously the correct size mandrel. And then also it's clearly labeled on the bar. It may be a little hard on the camera, but there are several settings that we could potentially need to slide our adjustment knobs to. So if in this case we're using...
This is where reading the manual comes in handy, because the first time...
Absolutely.
The first time I tried this, I had those knobs all the way in or out. I don't remember which one it was.
Right.
And I was bending a piece of tubing and then a total different size after. And one of the sizes, I'm like, I can't even get a 90 out of it. And I'm like, wait a minute, maybe I should read the manual. Yes, those knobs are adjustable for the pipe size you're using. And then everything was fine. So,
well, and you got lucky, because if you went too wide, you would just have problems getting the angle you want. If you were too far in, you'd break the tool potentially. So it can bind up, so we want to make sure we've got these set correctly. And then from there, you've got these kind of positive click swivel pieces to get the correct size tubing at that point, which I've got a 1/2 inch right here. We turn the tool on, we back it out. And then at this point, we go ahead and slide our tubing in. And then once that applies pressure, we can go ahead and let go with our guiding hand on the copper. And from here, it's a positive stop the second I release the button, versus waiting on each graduation of the ratchet mechanism, which is a predetermined, situation. If we top the tool out, so I've gone until it won't go anymore, that is a 90. And from there, not a big deal on 1/2 inch tubing, but if you see this bar right here, and this was a happy little accident from Navac. This was more of a protecting guard. However, what we found pretty quickly is that this will literally eject the copper for you from the mandrel. And one of the pain points of this type bender, when you're using the larger tubing sizes, they really get wedged in there, and they could be a huge pain to get out. I've popped them out before, but the mandrel just pops out on the copper still. Mm-hmm. And it's really tempting to actually take a pair of lineman's pliers or something, or a wrench, and beat on it to get it out, which obviously is not the right response. So when we have something like this, again, 1/2 inch is not a problem anyway, but you can see that bar pops it out, and it would do the same with our 7/8. What do we got? We got some fat 7/8. You were what? You want to cut another piece too? Because we could show the process here. So we're starting. I guess I'm stronger today, Gary. I also went further than 90, I think. I'll show you.
But you could hear you were grunting and groaning.
Yeah, no, it wasn't easy. Whereas if I had to do, we're rarely doing one bend. A lot of times we're offsetting, and then we're coming back up. As if we had come. Now this would be a good example. We don't want to play around and miss it on
our knobs.
7/8. So put these back out. swivel back to our 7/8, done. And that was a true 90, whereas I had to guess with my manual bender.
Yeah, much quicker. And if you're doing a bunch of bends in a day or on a job,
Absolutely.
I mean, it's a no-brainer unless you want to work out while you're at work and build those forearms up, right?
100%, which clearly I have. It's, lots of activities can build up the required grip and all of that. If we take a quick trip into Swedge land, and that was lame. Again, different methods of doing this. I don't have the NTE7 here. I don't think it's possible, Jesse. But again, many options, everything from a manual style expanding tool, which we have. It folds up. It's got little magnetic handles. It can go in your back pocket, and really not something. Yes, it can expand copper. It's certainly not the best option. It's great for a technician in a pinch to be able to adapt something. That's really the way I look at it. I would never run an installation with one of these things to try to save on fittings. This is more of a tool that I would use. And maybe in post-production, Gary, you can put a picture of this on the NTE7. If you need one, I've got one that you can put on here. But the idea with that tool is, you're walking, you've got a suction line that you run up to a unit, you're walking, you accidentally step on it, you egg it out. Now you've got this oval open line set. This tool really can come in and get in there and reround that tubing into an acceptable form to make your termination. Also, it can save you in a pinch if you don't have reducers, bushings, things like that, where you've got to join two dissimilar sizes of tubing, type of thing.
Now, if you look at package systems, a lot of package systems, you don't see any couplings inside of them. It's all bends. It's very rare you see a 90. It's all bends and expanded tubing. So, I mean, I wouldn't mind doing a full install without couplings. If it saves time and it saves money, sure, why not?
Well, 100% for these.
Yeah.
I'm actually talking about the other one that it's like hand.
You're talking about the handheld one. Like
the little handheld
flaring
one that'll fit in your back pocket.
It's like a flaring block, and it's got a die, and you got to hammer the crap out of it to expand the tube.
Well, not even that. We have the like I said, I'll send you a picture, Gary. It's got two handles.
I misunderstood at the beginning what you were talking about.
It has a tapered spike. It looks kind of like shaped like the spike you'd hammer in, but this one has an opening mechanism, so it actually splits apart. And it lets you get it.
Now I know which.
Now
I know which. Yeah. Now I know which
That's
one you're
talking
about.
I yes, technically on the bottom end of the spectrum of offering, we have that, but I wouldn't recommend it for running an install. I would use that to get out of a jam.
100%
these
agreed.
would be your high production, high volume expanding jobs where this is a wonderful option. This is a hydraulic. This is actually our second version of this, where the weight is almost half of what it was, and it's got a very nice pop release mechanism. So when you hit your expanded limit, it's going to pop. It's not going to let you overdo it. It has a release up top here to release the hydraulic pressure. When you're done, pops it right out. That's during the middle of the swedge, though. If you need to stop, you can manually release it. However, that clutch mechanism now, when it pops, it also goes ahead. It releases the pressure. So it just pops, comes right out of the tubing. And then for people that want, really I'd recommend this for people that, they want obviously the obvious fatigue element to having a battery operated version, but also if they've already invested in the flaring tool or the bender and they're already on this platform of battery, it can make a lot of sense to just finish the trio and have 3 battery operated power tools that all run on the same 7-volt battery.
And I want to make an observation here.
Yeah, please.
So when it comes to the batteries, I find that when I was doing a lot of install work, I'm not doing as much as I did, but I would take all of my batteries for all the tools that I have, because I have all of these, plug them in on a job, let them charge for a couple of hours, whatever it takes. And I found I didn't have to charge them again for like 3 months. So the charge you get out of the batteries is pretty phenomenal. I mean, the amount of bends or swages you can get out of one battery life, it's pretty phenomenal, actually.
Well, and when we talk about capabilities and limitations of tools, a lot of times the way, a sales team or a marketing team they'll frame or phrase things in a way that is obviously trying to show in the best light. However, with these tools, I want to make it clear, when we talk about the number of cycles, like you just mentioned, we test them and we advertise the performance that we get out of the highest size tubing that these will handle. So in other words, when we say that the bender can do over 100 bends on a charge, that's over 100 7/8 bends.
Mm-hmm.
That's not, we could have a much bigger number if we we're being creative.
Yeah,
and we
went to
just
3/8.
use 3/8, it's
Yeah.
over 600 bends, per charge, and really kind of puff that up. It's the same with the flaring tool. It's the same with the expander. When we give our numbers, and for all three tools, it's over 100. The flaring is the highest, but they're all over 100, and it is with the top out size of each tool. So rest assured, as you said, these things do not need to be charged very often. So for the concerns of batteries and, what if it dies on the job? Well, one, if you have a power tool, most people have more than one battery. It's just that's kind of part of power tool ownership. It's just kind of part of the logic. But even so, even without that battery on hand, it's going to be very rare that you're caught with a dead battery on these tools. I mean, if you've done 100 plus flares, put it on the charger. You know what I mean? Likely you're going to be at that point where you're in the field and all of a sudden it dies because you've done that much. So something to bring up, I always like to bring this up with swedging too. Another thing to keep in mind, just like with flaring, when you cut your tubing nice and square, a nice deburring job on it, and you can get ahead of that by not over torquing your tubing cutter while you're cutting. Another thing, when you're orienting these swedges, if you can help it, try to have your cup, if you've got two pieces on an existing piece of equipment and you've got to pick one of them to expand, I would expand the one that's on the side that the flow is coming from. This isn't like going to make or break your job, but if we're going over the top right now on just best practices, when it's doable, when you think of it, it's just one other way to minimize the impact, the negative impact on velocity and flow on these connections. Because no matter what you do, there is an impact. Anytime you have a joint, anytime you have a bend, anytime you have a fitting, is velocity and pressure drop consequence associated. So one way is to not have that refrigerant flowing against the swedge you made and the burr that's potentially still there.
Yeah, so I'm glad you brought that up. And a funny story, I actually used one of your tubing expanders. This is going back like 5 years now. And I think it was a 3-ton condensing unit. It was in a commercial application, but it was a residential unit on a roof. And there was a leak in it. There was a leak in the coil at the bottom, and it was leaking in 3 different spots, kind of in the same area. So I had to cut the pieces of pipe out. And what I did was the 3/8 pipe that was there, I expanded each end, like I swaged each end, and I put it in and then brazed it. So basically each end of that, it was going into a swage and coming out of a swage. And the amount of people online going, "You can't do that, bro." It was nuts, right? But I'm like, the repair looked good. It worked. It's not going to make that much of a difference in that scenario. It's either that I put 2 couplings on, give myself 4 joints now rather than 2. So that's how I decided to do it. But some of the people online were stating what you were stating is, and you shouldn't. And I agree with you. What you said, wholeheartedly agree with you. But you said if you can and when you can. And in this case, this scenario, I found it was easier just to swage 2 ends, shove them in place, and braze each end up, and I was finished.
And I call that a job well done. And that's why I was very careful to say if and when, because I may be here in a lab setting, but I came here from the field, and I know you're a veteran of the field and of social media, so you know how people love to talk. And we also know that at the end of the day, service is the real world, and sometimes you've got to get the job done, and you've got the customer's priorities have to be your priorities first. So you needed to get a system up. You got it up. I think one connection where you had a double swedge was not going to bring that system down. While you were telling that story, Jesse went ahead in the other side of the room, and he really mashed his tubing cutter to cut a piece of tubing. And I did one very softly here just now.
Yeah, you can see the difference.
Bring them up. Now they're even. You can see where the shape is malformed. It looks smaller almost.
Yeah.
Now that they're side by side, mine is right here. It's smooth, it's square. His burr, it's negligible whether his burr is much bigger, but it's definitely rounded. You can maybe that's a better
picture. And you can see at the top, it's more tapered.
It's rounded, at either side.
Yeah.
Now, it's interesting that we bring up rounded side. You don't want this for this situation. However, we've used this deburring tool so far, but of course, we have this double-ended is a little more expensive, but it's a little bit easier on the copper in the way it removes material. It does collect more material versus just kind of falling everywhere. And then it does have the other side, which a lot of people, for some reason, think they need to always use this. This is not necessary most of the time, but what this will do is it does shave off the sharp edges of that right angle if you were to hold a profile look at the tubing. And where I see that mostly come into play is for the emergence of these press tools and press fittings where and I have actually experienced this firsthand early on when those tools were really hitting the scene. I had the opportunity to use one on a job that mandated no open flame. So this entire big VRF job was 100% press fitting. And I'll tell you what, I didn't take it serious at first until I witnessed the improper prep of the tubing. I did not put that chamfer, which is what that edge is called. It's the chamfered edge on a piece of tubing. And as soon as I slid that fitting in, I severed the O-ring. And that is the risk, when you're hinging an entire job on those O-rings and those fittings, you want to make sure you're not, slamming them up against the razor sharp right angle tubing. So,
Yeah, man.
Another point to bring up when we're talking about the profile of the tubing. So if we've got our piece here, just like always, we want to deburr it unless I have no way to remove the shavings. In that case, I may omit this step, but honestly, I think 99% of the time, even if you can't turn it down, you can probably put some positive pressure on the unit with nitrogen in some way and at least keep things from entering or minimizing what will enter that tubing. So I've got a 1/2 inch here. And again, this is one button operation. I press it. I can let go if I need to. If it's up in a ceiling, hard to reach. Pro tip, got to put a battery in it. So give me a second. Take the battery out of my bender. And then one of the big things that people get hung up on with expanders is the tendency for smaller diameter tubing to split. This can happen. And I found that there's many factors. I've done a lot of experiments with this where I have, for example, used this hydraulic and I have just aggressively gone to town on it. And I've had it not split. I've had it delicately done and I've had it split. So I think you've got many factors. You have the operator on how they're using the tool, of course. You also have the quality of the copper. You have the quality of the job you did deburring it. Because again, if you over deburr this, you remove too much material, it's going to split. There's just many factors. And then there's just the idea of, 1/4 inch tubing. There's not a lot you can do there, but what you can do to minimize the issues is to, and I would only say this is necessary for 3/8 and smaller. I do have just 1/2 inch here now, but you can always, if you're worried, if you've already split one, you can cycle the tool, you can stop it, you can release it, turn it, press the tool again, stop it, release it, turn it, start the tool. You can do it as many times as you want, 3 or 4 times, and then you can reduce the risk of it just opening up too quickly and splitting that copper. So that is, you can do that with a hydraulic, you can do that with a manual, and then you can also accomplish the same strategy with even a power tool.
Sweet, man. Well, Andrew, that was very cool going through all of those. Unfortunately, I have to get going because I have another meeting I got to get to, but this was great. Jesse started it off with A2Ls, and hey, you're not wearing your hat anymore.
Your hat came off.
There you are. There you are.
Off.
Cool. So, all right, man. Well, I really appreciate it. If you got anything to add quickly about tubing tools before we head out?
Just again, keep in mind, it's not just tubing tools. Navac's categories in general, whether it was recovery and vacuum pumps like Jesse went over, tubing tools, keep Navac in mind regardless of budget and niche in the industry. If we have a claim to fame and something that truly can't be argued by our competitors, it is the range of application and options that Navac offers its customers. Whether you work on a PTAC unit in a Motel 6, centrifugal chiller in a cooling plant at a university, we have specific products for those specific applications. We're never going to try to stick one tool in your van because that's easier for us and tell you that it's going to do the job. And one final note with the A2L conversation, we're the last in line. We're the bottom of the totem pole on A2L information. So the tool companies have to respond to the equipment manufacturers. They're responding to Chemours and DuPont and the refrigerant manufacturers who are responding to the EPA, who is responding to whatever, presidential administration is in office. So it's definitely it's a process that we're following. We're making adjustments. We're keeping a close eye on it, but just know everything's subject to change right now. But the one thing I'd have you take away from is don't let any manufacturer try to scare you into completely replacing your entire. If you have manufacturers doing that, it's disingenuous at best, and it's an outright lie to capitalize on a situation at worst. We are making tools that we anticipate being compatible with requirements down the pike. But just remember, for those of you that were around during the transition from R22 to 410A, that was way bigger of a deal, way more of a legitimate change in practice and priority. What I really take away from the A2L changes you see is that nothing's going to change. Your practices are almost identical. It's just you have less wiggle room to cut the corners. It's all it's almost all stuff you should have been doing already.
Yeah.
But now it's just, you
I
need
totally
to really
agree.
pay more.
The 410A change was huge because it was higher pressures, different manifolds and hoses and all that kind of stuff. And going from mineral oil to POE oil, it was a big change. Pulling deeper vacuums too, nitrogen brazing, all that kind of stuff had to change in order for a system to have the long life that it should have. And there's still techs that don't even believe in any of that. It amazes me.
Right.
Probably amazes you, but this transition here should be easier for us, like you said.
I really think it will. And again, Navac's ready when you're ready to replace your tools. And if you're wanting to keep the A2L changes in mind, we've got wonderful options. But I think if you've got people banging on the door right now and trying to scare you into taking a loan out, kick them out. Kick them out of your shop, kick them out of your distributor, kick them out of your face, really, because they're trying to take advantage, and that's not what we do here. So I appreciate you having us on to talk about some of these products.
Oh, man, this was awesome. Thanks, Andrew. Appreciate it. Thanks, Jesse, if you're in the back there listening.